Okay, so we are in Statistical Rethinking, second edition, chapter 11 questions, the medium hard questions, and it's the last medium question, it's 11M8. Okay, so we are going to revisit the data Kline, the data set called Kline that is in the Rethinking package, islands example. Okay, so this example was presented earlier in the chapter. I'll read the rest here in a second. But basically what was happening is we were modeling the number of tools that were in some of the Pacific Islands as a function of log population. Okay, and then we kind of broke the islands into high and low population islands. Okay, anyway, during that, we found that the island of Hawaii was kind of an anomaly because it's a low contact island, I believe, but it seemed to be carrying a lot of the weight. So, for instance, if we ran PSIS, we found that it was doing a lot of work to shaping the coefficients of the regression. Okay, with that in mind, this time we are meant to drop the island of Hawaii from the sample and then refit the model. And what changes do you observe? Okay. We're just going to get this set up. So this is just, so what we have here is just the model from the book, okay, M11.10. And this is just as it is in the book. So I'm just going to rerun that so we have something to compare to when we drop Hawaii. Okay, so there's nothing new here. But now we'll get the other one going. So I'm reloading the data, I am dropping Hawaii, and then I am standardizing the variables. Okay, I think that might be important here because if we're pretending that Hawaii doesn't exist, we don't want to standardize with reference to Hawaii and then drop it. So I think that probably makes sense. But anyway, so I'm doing the exact same thing, but I just have this slightly different data set that doesn't have Hawaii. And I have, so I'm calling that D2. So this model, instead of being 11 or M11.10, it's M11.10B. Okay, and we've ran all of that. Okay, so now I want to compare these, and so I'm just going to plot, I'm going to make the same plot that was in the model between the two data sets. Okay, and so this code, I won't go through it because it's copied exactly from the text, all of this. Okay. But I'm also going to do it for the other model, for both models, the one that's in the text, the example in the text, and then what we are working on here. And then I'm going to display the plots next to each other with this par function. Okay, par mf row 1, 2 means there's going to be one row with two columns. Okay, so that's what we have here. So what we have is I believe that the solid dots are the high contact islands, and then low contact islands are the unfilled one, and then we have the lines of fit for high contact being solid and low contact being dotted for the two models. Okay, so we're supposed to compare what happens when we drop Hawaii out. So I think that this guy right here is Hawaii, and notice it's not in the second model. Okay, so there's a few interesting things here right off the bat. One is that notice the scale of the axes here, right? Because we are dropping Hawaii, which was the most populous island here, at 2 standard deviations above the mean, and now we are, we don't have Hawaii, so we've truncated the x-axis here. Okay. Now, what seems to me to be happening is, at least through the population ranges, is that probably call it the slope, even though it's not a consistent slope, but that the trajectory of these regression lines, whereas here they kind of start on similar trajectories and eventually converge, these ones look like they are maybe diverging more, but that's really just an eyeball test. But what we could say in the left model here, in the original one, is that it certainly seems that this trajectory, and we'll call it the slope, again, even though it's not a consistent slope, looks to be very different between the two models, or I'm sorry, between the two lines. Whereas in the second model, where we've dropped Hawaii, the slopes seem to be maybe more similar, or even, so I suspect that the slopes are going to be more similar. And then the other thing too is, in the first model, the dotted line seems to be raising much faster than the solid line. But over here, it seems to be the opposite. It seems that the solid line might be rising faster than the dotted line. Okay, so the magnitude of the slope, again, a term I'm using very loosely here, but the magnitude of the slope seems to have reversed between the two plots. Okay, so we can actually try to see if our eyeballs are deceiving us down here. So I'm just running the Pressey outputs summaries. Okay, and so what we do in fact see, so in the first model, okay, we see that there's some size of a difference, and that difference seems to be smaller here for the second model. And it also seems to be correct that whereas in the first model, B1, the dotted line, was much greater than B2, but the rank of their sizes seems to have flipped in the second one. Okay, so I think that is it here.